This conference will now be recorded.
Fine. So before I get into the session today, again, if any of you have any questions, clarification on the topics, on the course content, feel free to put it in the chat. Or if you wanted to probably ask question, we can probably spend 2-3 minutes before I start the session today. Okay, fine. So what I will do today is, again, for few of you to understand my style of teaching, the way you will understand it, for you to get a clarity. I'll just pick one of the topic from uh, the course, and then I'll go over that in another 30-40 minutes. Okay, so that you'll get a better idea of whether you understand my style of teaching, or you able to grasp the content, right? For you to get a better understanding before you go and register it, I thought I'll spend 30-40 minutes on any of the topic randomly. Okay, so what I will do is I'll go and pick the topic of the threats. Okay, thread states, thread contentions. We'll try to probably execute test in Jmeter, configure the application threads, and then monitor the thread state using JVisual VM and AppDynamics. So we'll try to learn this topic today. Completely an off topic. I mean, though it is an off topic, it is part of the course anyway. Okay, fine. So if you remember yesterday, I was mentioning about these boundaries, right? Your specification of your hardware is going to be with respect to CPU, with respect to RAM, and then assuming that you have a Windows laptop or a Windows server, you will have the specification of 8 core or 4 core, and then 8 gig RAM, 16 gig RAM, right? And then on that mission, you will be going and deploying your application, right? Your application will get deployed in a, say, JBoss or a Tomcat kind of a server, right? So for your application, then you will configure what kind of memory you want. That is what we call it as a heap in terms of Java, right? So you will configure the heap, you will configure the threads for your application. So there is always going to be a certain boundaries. A boundary is going to be within a CPU, within a memory. For your application, boundary is going to be on your heap, on your thread. So within this boundary, your application has to work optimally, right? So we will learn about this benchmarking. What would be the upper limit? What would be the minimum limit? How CPU, memory, heap, thread, response time, all are interconnected when it comes to capacity of your JVM, right? We will learn that later, right? So from a thread perspective, thread you can just think of as a task handler, right? So you get a request from say a browser. Say if you take an example of bankofamerica.com, right? A net banking site. So multiple people will be accessing the net banking, right? And then there will be a transactions for login. It would be for some third-party transfers, looking into the statements. So there could be multiple such requests coming into your server. So your thread is a kind of a task handler which is going to handle these individual requests that is going to come from your browser, right? So each thread will be responsible of executing that particular program. For login, it will be a login class file. For view statement, there will be a statement related classes and method. So each thread is a task handler which will be responsible for executing the particular piece of code. We'll just think that we'll just try to visualize it a thread as a task handler. Okay, to even more simplify this, I will try to probably give an analogy. Not a perfect way of explanation, but easiest way of understanding it. Okay, you all might have used all these Swiggy or Zomato kind of apps, right? Food delivery apps, right? And as you all know, the way it works is you at your home, will be ordering the food, and the other end there is going to be a restaurant who is going to prepare the food, and then they are going to send it through the Swiggy delivery people, right? So there are going to be many such delivery person working for Swiggy who will be waiting for the orders, right? So in between you who is ordering a food and the restaurant who is going to serve the food, there are going to be multiple Swiggy delivery person who is going to wait until there is going to be some orders going to come in. And when the order is going to come in, randomly the request is going to get assigned to the person who is idle or who is free, right? And then he will wait for the food to be prepared, and then he will receive it, and then he will deliver it, and then again he will go and go to a idle state. Or if there is another request, it will be assigned to him as well. Similarly, multiple orders, multiple such requests will be randomly will be allotted to these people who are available, correct? And to add some more complexity to this, you might be having a very good demand in the late in the evening, or maybe in the early morning during breakfast. Otherwise, during the daytime, you might not have that kind of a demand, correct? So to handle this kind of peak hours, off peak hours, the strategy would be by Swiggy to employ more people in the morning hours and in the late evening hours. And then during the daytime, they will probably just go with some minimum 3 or 5 people, right? So in the peak time, they might be having some 10 or 15 uh, delivery person, and then in the off peak hours, they are going to be only 5 or 6, right? So that's how most of these food app works, right? Now, when you're going to just compare this with the way the thread is going to work in your server, there are going to be many threads that is going to be created and will be waiting, right? And whenever there's a request going to come from Bank of America users, the request is going to get randomly assigned to a thread which is free, right? So if there are 10 threads, 10 each of the threads might get assigned with a multiple request coming from 10 different users, right? So when they completed the task, they'll again go and sit idle, right? So multiple threads will be handling multiple requests, and then they will be moving between idle and busy, depending upon the traffic. Similar to the Swiggy, for our application will also have a definitely will have a peak hour, off peak hour, right? Sometimes maybe during the morning between 9 to 11, Bank of America, right, being it's a net banking, people might be using it maybe during the morning hours, or maybe in the late evening hours. There might be some pattern, right? Uh, so here what will happen is we will not know exactly when the traffic will be high, when the traffic will be low, right? Because it's a Bank of America net banking site, you never actually can predict the traffic. Though you will have a pattern in production, but you will not be able to exactly say this is an hour where I would be having the more traffic. So to suit this kind of a requirement, again in a server, you would be able to say when there is more traffic, use 100 threads. When there's less traffic, just use 50 threads. That kind of a max and minimum you can configure in your service. It's a similar to the way your Swiggy operates, but there it's going to be we know which is a peak hour, which is non-peak hour, so it will be a fixed one. But here it is going to be a between a range. We will let the server to choose when to go with the minimum, when to go to the maximum, or in between, right? So it can go up, it can come down, but it can never go below the minimum or go above the maximum. Okay, so first, just for your understanding, you just remember this analogy. but nothing to really compare with the way both are going to operate. Okay, so which means your threads are going to have a multiple states, right? It's going to get created when the JVM starts, when your server starts, your threads will get created, and then it will be ready for taking the task, which is what we call it as a runnable or parking. Different tool might show a different status, but generally a runnable or parking is nothing but it is idle, it is ready to take the work. So which means the status can be runnable, parking, or idle. All three are nothing but thread is ready to pick the work. It is idle now. From there, when the task is assigned, it will go to a running state. Again, it can go back to the idle state. In between, the threads can also go into a waiting state. Okay, waiting can be because of some thread dot sleep. Maybe a developer would have forcefully wanted to wait a thread for a few milliseconds. So it can be waiting because of a thread dot sleep that is written in the code, or it could be because of some underlying problems. There can be a block. A thread can get blocked by other threads. Okay, we'll go and understand these blocked state, how to understand why it is getting blocked by taking the thread dumps and all. We will be looking into it later in the sessions, right? But from a thread state, blocked state is not a very good thing to have. You cannot really avoid the blocked state. There can be a blocked state, but how long a thread is going to be in a blocked state is going to impact your performance. Okay, we'll try to understand it later. But for your understanding of the various states of thread, it is going to be idle, busy, and waiting or blocking. Right? Those are the three states where your threads will be moving in between. And the additional threads which are getting created, right? Say you have given 100 threads as minimum, 150 as maximum. During a peak hour, the thread can go to 110, 120, 125. When the traffic is going to come down, your maximum thread from 125 will come down to 100 again. So which means it will get terminated, but the thread count will never go below the minimum value. Okay, for example, for our e-library application, right? If I go to the Tomcat configuration, I go to the configuration, I go to the server.xml. So here I will provide the for e-library application, what is the minimum thread that is required, what is the maximum thread that is required. Right? If you see here, I have given a minimum thread as 4, maximum thread as 6. Okay, I can give again 100, 150, 200 depending upon my requirement. That we will discuss later when we come to benchmarking. What has to be this value? For our understanding of the threads, I've just given 4 minimum, max as 6. Okay, what I will do is I'll go and probably I'll stop this. I was running a Jmeter test to show something. Let it get stopped. So what I will do is I will go and open the JVisual VM. Again, JVisual VM is one of the other Java monitoring tool, which you can download it from my drive, or you can download it from the internet also. Okay, I'll use JVisual VM because it has a good plugins to look into these thread states, and also there's one more plugin for garbage collection as well, which I will show you later. Okay, for JVisual VM, I'll just open the JVisual VM. Okay, you can just double click it and then you can also open it. It will open. Sometime there might be, if you have two or more Java version installed in your machine, you may have to, sometime it will say that the visual VM is not compatible. Okay, that time you have to exactly provide the Java version which you have to open the visual VM with. So I'm just giving visual VM -jdk home and your JDK file. Okay, I'll tell you about JDK, JRE, JVM, configuring this Java environmental variable, probably if time permits today or in the next session. Okay, but for visual VM, you can download the visual VM from my drive, or you can download it from the internet also, and then just double click it. It should work most of the time. If it doesn't works, then you let me know. I will tell how to open it. Okay, I'll go to this application and then I'll select the Tomcat. It will show all the Java related applications that is running in my machine. So in my machine, Jmeter is running. So it is also showing the Jmeter because Jmeter itself is a Java based application, and it is also showing me Tomcat. I'll select the Tomcat and I'll go to a threads. Okay, in the threads, what I will do is I'll just go and select my threads. So if you see here, 1, 2, 3, 4. These are the 4 thread 8083. If you look into this configuration also, I would have given the port 8083. Okay, 8083 is a port in which my e-library application will be launched. Okay, localhost 8083/e-library. Okay, again, deploying this e-library in a Tomcat, I'll tell you today before we close the session. I'll tell you how to deploy the WAR file in the Tomcat. Okay, so my e-library is running in 8083 port, and then in the visual VM as well, I'll go and select these 4. Okay, let me not even select it. If you see here, we have given 4 as a minimum, right? I've given the minimum as 4. So it has created the 4 threads, 3, 4, 5, and 6. Okay, and all 4 are in orange state. Orange means it is parking. It's runnable. It's idle. All 4 threads are in orange state, which is nothing but a park state. If you see the bottom of this visual VM, you will see running, sleeping, waiting, parking, monitor. Running is when it is busy doing some work. Sleeping, waiting, monitor, all 3 are kind of a waiting only. Okay, the sleeping is something where it is explicitly sleeping because of the way the developer has given some thread.sleep in the code. Waiting is when it is waiting for some of the system, your Windows application. It might try to access some Windows application, or it might be waiting for the other application to respond. It will be in a waiting state. Monitor is blocked state. You will see a word of monitor or blocked. Both are sometime it will be used interchangeably. So monitor is nothing but a blocked state. Now what I will do is I'll just go and start this Jmeter test. Okay, so Jmeter test, I'll probably run it with some 8 concurrent users. Okay, so which means concurrently there will be multiple requests that will be coming to your server, right? So which means this 4 might not be enough. So what your server will do is it will go and increase the thread from 4 to 5, 5 to 6, not more than that. Now if you see, all 4 threads are getting assigned with some work. It is going to green, it is going to gray, it is going to monitor state, it is going to toggling between all 4 states. Okay, now if you see, additionally it has given you 3, 4, 5, 6, 7, 8. 6 threads starting from 3 to 8. It has given you 2 more threads, and all 6 are moving between running, sleeping, monitor, parking. So it moves between various states. That's how every thread is going to work. Because from Jmeter, I'm sending a load, right? There are multiple transactions that is happening from your Jmeter to your app server, right? So that's how your threads are going to get created. Additional threads are going to get created as per the demand. And once I stop the test, right, you will also see that your these additional two threads will get terminated. Okay. And one more thing, what I want to show is, say for example, if you use tools like Dynatrace or AppDynamics, right, you will also see one more interesting thing. Let me go to the this AppDynamics is connected to the my e-library application. You will also be doing it in the upcoming sessions. If you go to the e-library application, if I go to the TS, if you see here, let me go to the dashboard, and you see something called code problem, right? One of the functionality in AppDynamics is it will show you the if there is any severe problem with respect to heap or thread or GC. We can create those kind of alerts. We'll discuss about alerts and all later. But once you set those alerts, you will be able to see all those problems getting highlighted here. For example, one of the problem that is showing currently here is resource pool limit reached. If we click that, it will say thread pool has reached 80% limit. Current pool size is 6, max is 6. What is saying is only 6 thread is configured in your server. All thread are used, which means your thread utilization is almost 100%. It's very busy, so it is giving a alert, right? And if I and in AppDynamics also, I can go and monitor the threads. If I go to the TSN notes, we will learn about AppDynamics anyway in detail later. Since I have started this thread topic, I just want to show you the relevant aspect in the AppDynamics as well. If I go to the JMX metrics, if I go to the JMX, go to the web container runtime, and go to the A083, you will see the busy threads, current thread, maximum thread, right? Maximum thread is going to be 6 because we have configured 6 as a maximum. And then if you go and click your busy threads, busy thread, if you see, before we started the test, right, it was somewhere in 3, 2, 3, 2, and it came down to 0. Now we started the test as 9:25, right, 3-4 minutes before. Now the busy thread is at 6, maximum at 6. So both your maximum threads and busy threads are at the same level of 6. That is why you see in the alert as well in the home page. Okay, now if I go and stop the test, right, let's see what happens. I will go and stop the test. After a few seconds or a minute, what you will see is your max thread from 6 will come down to 4. You will see those two of those thread will get terminated. And in AppDynamics also, you will see that maximum thread will come down to 4. Okay, it might take few seconds maybe, or sometimes a few minutes for this to get reflected. Now if you see, all the 6 threads are moving to a parking state. Slowly and steadily, all 6 threads are moving to a parking state. So once your server witnesses such kind of a state, say all the threads are now idle or most of the threads are idle, then it will try to terminate the unwanted threads, because even if the thread is idle, it is going to consume CPU. Okay, so your server will try to optimize the CPU. For that, it will try to go and kill those. Maybe it will take few more seconds for this to happen. So I think now it came to 5, it came to 4. Yeah. Now if you see here, 3, 5, 6, randomly it won't go with some sequence and all. Randomly it will go and terminate the additional threads. Now it has again come back to 4. 3, 5, 6, 8. Right? So that's how your threads are going to get created and terminated between the range of min and max what you configure. Okay, so during your load test as well, so there is two things. One, you during your JVM benchmarking, you have to specify, you have to run multiple tests and then arrive at a proper min and max. That is one exercise. That is one of the performance engineer's role. We will learn later. Second is during a load test or endurance test or stress test, you will monitor your busy threads and the number of threads in the pool. That you will monitor. This will give you the thread utilization. Okay, and then one more thing is if there are without any reason, if thread utilization is very high, your CPU is also increasing, then there are symptoms for the thread going into a blocked state. That time we will go and take a thread dump. All these are all various things that we will handle as a performance engineer from a thread perspective. During JVM benchmarking, you have to run multiple tests and then configure the threads. And during load testing or any performance testing, you will monitor the thread utilization like this. And if without any reasons, if a load is under load, if you see that CPU is increasing, your thread utilization is also increasing, then we also go and take a thread dump and then analyze the thread dump. All these different aspects we will learn later, but more from my introduction to the thread, I just wanted to give you all these explanation. Okay, if I go and refresh it after a few seconds, yeah, you'll see that at 9:30 your max thread, if I go and again refresh it last say 15 minutes, okay, you will see that your busy threads came down to almost 0 now. Okay, and then if you go to the JMX and then look into the current threads in the pool, it will show as 4. Okay, it will show as 4. From 6, it has come down to 4 because 2 threads got terminated. And out of these 4 threads, all the busy threads are 0. So there are no threads that are busy, and you have 4 threads that are available in the pool. Maximum it can go up to is 6 when it is required. So maximum thread is 4, current thread is 4, and then busy thread is 0. Okay, so before the test, after the test, during the test also, you need to monitor your thread utilization, which is very, very important. Ideally, thread utilization should be around 65 to 75% during your load test or even in production. It should not be underutilized. It should not be overutilized. So optimal for even CPU, memory, threads, everything, it should be optimal. Never it should be underutilized or overutilized. So as a performance engineer, it is equally important not only to check whether the CPU is high or memory is high. Same way, if it is very low also, you have to give that feedback to your architects or infra team, saying that unnecessarily you're configured high heap or high number of threads, but during the load test or stress test, the memory or heap or thread never crosses 20%, which means they can lower the configuration so that those resources can be used by some other application. So that feedback, even if it is low, that feedback has to go into your architects or the infra team. Okay, I'll take a pass here, guys. Anybody have any questions on the topic? Again, this is more of a kind of introduction, but still, if you have any questions, feel free to ask or put it in the chat before I go to the next topic. I'll just take some
Satish,
water. Give me a
Gautam
few
here.
seconds.
Oh,
Yeah,
sorry.
go ahead.
Yeah, I'll wait.
Yeah, go ahead.
Yeah, so I would like to understand, like you have started a Jmeter test, right, Satish? So how many users have you configured, and what is the connectivity between the users and the threads in the test? So I understand the threads are the task handlers. So like even when we are triggering with the two users, is it like six threads will use, or how the users and threads are connected? To understand from a JMeter or a load runner test.
Okay, so it is not actually the users and thread. It is more about
Okay.
the request and thread. Okay, so with say if I have two concurrent users in my test, and there might be multiple requests, right? There's going to be home page, there can be login and a view librarian. Within login view librarian, there might be multiple services as well, right? And each
Okay.
service, each is a request. So it depends upon how fast one request is getting completed, because a thread is going to handle a request only. It is not going to handle your entire concurrent user sessions. It is going to handle, it will not even know it is coming from the concurrent user 1, 2, or 3, right? It is going to just receive a request. And if a request can be as simple as maybe an API call, which can complete in 100 milliseconds, or it can be a complex request which can take you in 5 seconds, right? So from a count perspective, you cannot directly relate the concurrent users and the number of threads, right? uh, it is more in terms of the request will be handled by your threads, and the thread will complete that request within 550 milliseconds. It can go and pick the another request. If a thread is going to take 5 seconds to complete a request, then for that 5 seconds that thread is going to be busy, right? So it is in terms of relation, it is going to be number of requests that is coming into your application. How fast a request is getting completed, a thread can go and handle the another request. That's so there's it's see, obviously, if with more concurrent users, more request. With more request, you need more thread to handle it. If you configure less threads, then your response time is going to be increasing, because they have to wait. Only the thread, after
Okay.
completing one request, it has to handle the another request. So that's why you see normally what will happen is, when you run a load test, everything will be all good. When you go and run a 2x stress test, your response time will get shooted up, because you wouldn't have went and altered your thread count. Normally for a stress test, you might have to go and increase your thread count. If in case already during a load test your thread utilization is 70 or 80, that's how it is related.
Okay. Okay. So, for my understanding, I just give an example. Say a user is clicking a home page. So, clicking a home page is one request, or the home page will have multiple web requests, right?
It can, yes, it can have multiple
Okay.
requests.
Okay. So, based on the availability of what to say, idle threads, like each sub request also will be picked by different threads based on the availability. Is it? Or
Correct, you're right. Correct.
okay.
Absolutely, yes.
Okay. Okay. Yeah. Thank you, Satish.
Sure, no problem.
And
Couple of
one more
questions.
thing, and
Yeah, go ahead.
regarding the monitoring state, like you have shown, right, during the
Mm-hmm.
there are different types of phases like running,
Uh-huh,
monitoring,
uh-huh.
idle, right? Like what is monitoring?
Yeah, monitoring is the blocked state, right? In some
Okay.
kind of an situation, there is something called synchronization in your programming, right? Where even though your most of your applications are supports multi-threading, because of some functionality, there will be a restriction in handling some piece of a code concurrently. Okay, in that time, what will happen is, say there is to keep it very simple, there is a method in your Java application which can be accessed only by one thread at a time. For example, then what will happen is, say that is a login method. Okay, If 5 login is going to happen concurrently, then when it is coming to that method, 4 thread have to wait till your method is getting completed. That time, all the 4 thread will be in a blocked state. That blocked state is
Okay.
what we call it as a monitor state. Okay, so thread can get logged by another thread due to some kind of restrictions or some kind of functional logic, whether it is written correctly or implemented incorrectly, that can impact your threads. So when a thread is going to get logged by other thread, it will be in a monitor state. Only the thread is completed the work, the other thread can enter the that code and it can get executed. So monitor is nothing but a blocked state. Because of the blocked state, what will happen is your response time will increase, your thread utilization will increase. Okay, so you need to know when that happens. We go and take a thread dump, understand how many threads are in blocked state, why it is getting blocked, and whether the blocked state is there only for a few milliseconds or if it is there for 1 second or 2 seconds, and what is the root cause of the that block. All these things you will be analyzing in your thread dump. So to answer your question, monitor is nothing but a blocked state.
Okay.
Yeah, there is one question: in real time, can current thread count go below minimum thread count? No, it cannot go below minimum. See, both for heap and thread, conceptually both are little similar, right? So it can be operate only within this two range. It cannot go beyond 6. Even though the traffic is going to increase, it won't go beyond 6. Same way, your thread minimum thread cannot go below 4. When JVM starts, you will get 4 threads, and until your JVM is going to get terminated, 4 threads will be alive. So your current thread count cannot go below your this minimum criteria. Okay. Another question is, explain this sleeping state. Okay. See, sleeping state is, I don't know whether you might, if you have already used load runner or Jmeter, right? You know that in load runner we give think time. In your Jmeter also, you will be able to uh, make um, uh, your Jmeter thread to wait for few seconds, right? So which means you're explicitly halting your progress, halting your execution. Similarly, in your programming also, developer, for whatever reasons, you can give a thread dot sleep in the program. If that is given, your thread will sleep for those milliseconds or few seconds. There might be some retrials. It might be trying to reconnect and with your database. Whatever reason, they might give some thread dot sleep. If so, your sleep, your whatever the state of sleeping, what you see is the when thread is going to sleep. It is actually running. It is doing some work in between. If there's a thread dot sleep, it will go and wait for those few milliseconds or few seconds, and then it will go to the running state. So it is exactly equal to your think time in load runner or think time in Jmeter. Okay. Yeah. Okay. So, yeah, next 5-10 minutes, what I will do is, since next Saturday and Sunday is going to be a weekend, right? I want you to do setup to be completed over the weekend so that you will be able to do hands-on as we start the sessions from continue the session from Monday, right? So, couple of important things. One is in your laptop. Okay, go to the command prompt and then check whether the Java is available or not. Java hyphen version. Okay, you should see 1.8, or it could be Java 12 or Java 14, whatever it is. Okay, check it out. If Java is not available, go and download the Java from the Oracle site and install it. Very straightforward. Try to install Java 8 if possible. If not Java 12, don't install the very latest version and all. Maybe Java 8 or Java 12, Java 14, you can go and install it. Okay, it's very straightforward. Go and Google it to download Java, you will get it. Once Java is installed, what you do is go to the environment variables. Okay, and then check for the couple of path variables. It is little slow. Let it come. Yeah. Go to your, in the control panel, go to the environmental variables, system environmental variables, and there you have to, while you install it also, it'll get automatically, this variable might get added, but just ensure that in the system variables you should have a Java Om. Okay, so Java should be pointing to your bin folder. Wherever you install Java, C program files Java JDK/bin, that should point to your Java, and then your JDK path should point to your Java Om. Okay, so just make sure these two things. And then also, if you go to the path, okay, go to the path, and then again provide the you go to the new and provide that /bin, C program files Java JDK bin. Okay, so you should have the Java Om and the path variable as well. Very simple steps, no complication at all. Download the Java, install the Java. It's very click, 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 click. It will get installed. No complexity, no other challenges you will have. Once that is done, open the environmental variable and make sure that you have this Java Om and path. That's the first prerequisite. Once that is done, again open the command prompt and then check for the Java version. Open a new command prompt and then check for the Java version. So this is the first step you have to do it when you get time tomorrow. Okay, and then go to the drive. The drive, whatever I've given access to you guys. Okay, whoever has registered and made payment, you might have got that access to that drive. Okay, in the drive, go to the e-library war. Okay, and then download this e-library without DB APR 2024. Okay, download this war file. Okay, and then you also download the Tomcat from this folder. You can also download the Tomcat from internet also. That is also fine, not a problem. Or you download this tomcat.zip. Okay, so download it and unzip the Tomcat. Okay, and then go to the Tomcat folder. Okay, copy the whatever war file you downloaded, copy to the web apps folder. In the web apps folder, copy here. Rename whatever download war file you're going to download from the internet. I might be named as a e-library underscore thread, e-library underscore memory, e-library underscore response time issue. I might have given a different name for the e-library war file depending upon the usage. But when you copy to the web apps folder, always rename it to ecaps lcaps e-library.war. Okay, always like this. And then, okay, two things you have to validate. Very simple step. No, I mean, you don't need to worry or you don't need to get confused. Okay, download Tomcat, download the war file, copy to the web apps folder, and then go to the bin and go to this Catalina, right click it, and then open it in the notepad. Okay, from the top, if you come down, you will see this line number 116. Okay, you just can keep it the same memory heap 300 800. No need to change anything for now. Let it be whatever it is. And the lines below that, right, those 5-6 lines, wherever you see this kind of a folder structure, ddev, cdev, all these are all a folder in my laptop. So wherever you find this, just comment it out for now. You don't need this for now. Okay, just put rem, it will be removed. Right, this, there will be two entries, one for the heap dump, one for the AppDynamics agent. Okay, for now you don't need that. I'll tell when to add it. For now you just comment it out or even remove it. I don't have a problem. Okay, this alone you ensure that you do that. Otherwise, your Tomcat will not start because it will look for this folder. Okay, so just do it, remove that, and then save it. That's it. You no need to do anything at all. And one more thing is, you just ensure that what is in the server.xml, whatever we opened it here, right, for thread, just check that what is the port. It might be 8083, can be 8082, 8081, whatever that is there, just note it down. That's it. Okay, nothing else. And then you go to the Tomcat, and then go to the bin, and then go to the command prompt from here, cmd, type cmd from here, open, and then type startup.bat. Okay, then you click a start. I think it's my thing is already running. I'll just try to close it. Okay, startup.bat. Then your Tomcat will get started. Okay, it might take some few seconds or a minute sometime, but it should not be more than that. Okay, once the startup is completed, you will see a message saying that started. So you will see that server started in 2587 milliseconds. Okay, once it is started, go back to your web apps folder. Okay, you will see this folder getting created. Okay, you go to this folder, you will see all these files in the e-library folder. Okay, so see, the conceptually, right, a developer creates all this class file, and then he will zip it and then export it as a war. And you get a war file, you put it in the Tomcat web apps folder, and when you start the server will kind of unzip this file and then put all the files here for the people to access it. That's how conceptually it works. A developer zips it and creates a war. When you deploy to a Tomcat, it gets unzipped so that you can access the /login, /admin book form, /index, all these files. You'll be able to access it. All the underlying programs also will get executed accordingly. Okay, that's conceptually. You don't need to know this as well. For your understanding, I'm telling. Okay, so to know whether it is successfully deployed or not, you should see a folder in e-library, and you also should be able to see all these files. And then go to your browser and then open the localhost 8083 ecaps lcaps e-library. Okay, and then default login is admin at jtp.com admin 123. Okay, once you log in, you should be able to see the home page. I will ask the team to add another video as well, which I would have captured it exclusively for this setup. They will add it tomorrow morning along with this video. You can also refer that, or you can just refer this video itself, what I'm teaching. It should be good enough for you to set it up. Okay, number one, install the Java if it is not installed, configure the environmental variable, check the Java version, and then download the Tomcat from the internet or download the Tomcat from my Google Drive, download the war file, and then check the catalina.bat, check the server.xml, and then go and start the server.bat. That's it, right? It should not take more than 5-10 minutes, but you might get problems, because even if I go to install this in another new mission, I'll get some kind of a problem you never can anticipate with all these softwares, installation and deployment and starting up the server. Some kind of a issue you will be getting it, but always be open-minded to understand what is the problem. Go and Google it. You will find the solution for that very easily. Okay, so always ready to uh, um, uh, foresee these issues and expect these problems, and you will be able to solve it. When you get a problem and when you solve it, right, you will learn more than when something works for the first time, always. Okay, so just try to enjoy those kind of issues rather than worrying about a lot. If in case you got stuck, if you couldn't able to resolve, you just let me know, just send the screenshot, and I'll tell you what screenshot I needed. I can probably help you out over the weekend through message, or maybe if required we can get into a call. But please make sure that you complete the setup over the weekend. Okay. The setting for IIS will not be exactly same for other service. If you take IIS or maybe a JBoss or for WebLogic, the these things are going to be a little different, but conceptually it is going to be same. But you just need to find out. See, in some places, in some project, they will not even allow you to access these underlying files. They might have a UI, a console, or a web console, or a some kind of a tool, web tool, in which you can go and configure this heap or a thread, all these startup configuration. Some places you can go into the file directly. So it depends upon the project to project, but definitely from web server to web server, these things might change, definitely. And you no need to know everything by yourself, right? You, if in your project they are using WebLogic, or if they use the JBoss, it's just that you need to get that information from the server team. There are going to be dedicated server team. They might do a changes, or if we have to do a changes, get those information from them, and you can do it. You don't need to even think about I mean, whether they will give the data or not. They are the expert in the servers. We are not the expert on the servers, but we know what we want, right? So you ask the question, they will tell you, either they will provide you access to the console, or they will give access to the server where you can go and do it. But to answer your question, it's not going to be exactly same. Every web server, the configurations are going to be different. You just need to find out where to go and do these changes.
Makes sense. Yeah.
Okay, fine, guys, we'll stop it here. Again, if you have any questions on the registrations or payment, please do contact Kumar sir or the admins of the WhatsApp group, wherever you're part of, whichever group you are part of. And anything to the course content or the course, or whether it is applicable or not for your skill set, you feel free to message me. Over the weekend, we will try to connect whenever we both are available. Okay, but whoever registered, please send me your email ID in the WhatsApp group. I'll try to add it either tonight or tomorrow morning. Okay, we'll stop it here, guys. Anybody have any other questions? Feel free to put it in the chat, or feel free to voice over. Fine, yes. Fine, and we'll close the call today, and then we'll continue on Monday. Yeah, thank you.
Thank you,
Thanks,
Satish.
Satish.
Bye.
Have a great time. Great.
Thank you.
Bye.